Greetings, fellow scholars. Welcome to Excel 3, Scenario 3. On Scenario 3, we are going to be discussing Z-curves, probability, and confidence intervals. And when we talk about the Z-curve, you guys have heard the Z-curve called a normal bell-shaped curve. You've heard it called a normal distribution curve. And this is probably the first time you've heard it called a Z-curve. But you do remember stuff about Z-scores. And a couple of things we're going to look at is that sometimes you look at a Z-curve and you see all of these percentages and they look different. But in closer examination, everything's actually the same. Some bell-shaped curves report percentages as wholes. In other words, the standard deviations are whole values. And then you see in between the standard deviations are your percentages. Well, other bell-shaped curves report standard deviations as halves. So halves. So if you look here in this particular curve from 0, let me get my highlighter here. If we go from 0 to -1, we would add together that 15 and 19, and what would we get there? We would get 29, 34.1. 34.1 is what you do actually see right up here in this upper one, 34.1 approximately. So when you guys are looking at the different curves, just remember that the numbers are the same. They're just reported differently. So the upper curve reports whole standard deviations, the lower curve reported halves, and then we have this curve over here, and this curve reports whole standard deviations, but then it's also reporting portions. So it shows us from -1 to 1, we have 68%, and then from -2 to 2, we get 95.4%. So a lot of different percentages going on, but they all mean the same thing. The reason why we have also another thing that occurs here is that you might see sometimes our percentages are reported rounded to the nearest thousandth, while other times our percentages are rounded to the nearest tenth. And sometimes you might see a percentage reported as a whole integer, as well as if, depending on the data that's being reported, we might get a much more precise decimal value for the percentage. And the reason that we get that difference, the reason why we can find different values and it's all in so many decimals instead of just being whole numbers, is because the x-axis of the bell-shaped curve is a horizontal asymptote, meaning that that curve comes down on the sides but never actually touches all the way down on the x-axis. So we say we have 100% probability under the curve, but the real truth is we have 99.999999%. And if you guys look below this particular curve, let's make this bigger here. We have what's called percentiles, and we're going to look at percentiles here in a couple slides away. But our percentiles here are recorded underneath our standard deviations. So you see we have our 0.1 percentile, and then all the way to the right we have our 99.9 percentile. So if you ever hear that somebody took a test and they were in the 99th percentile, that's as high as you can go in this data because of that horizontal asymptote. And there are a lot more details to explain that, but we're going to leave that for when you take your intro to stats course. And for now, we are going to move on. And some of you may take intro to stats. You should all take it. It's a great class. All right, so moving along here, we are going to now look at the standard deviation. We remember that the standard deviation measures the spread of the data. And you likely remember that some percent of the population falls between some standard deviations. So for example, from 0 to 1, we have 34.1% of the population. From -1 to 1, we have 68.2% of the population. And you might remember that to identify your z-score, your z-score is just where you fall on this thing. A lot of you remember the Duke sleep study. And whatever that average was, I don't remember, let's just say it was 6.5. If some of you slept for 8 hours, some of you said your z-score was 8, but really your z-score was somewhere between 0 and 1. So that was something that we saw a lot, and I've discussed that before. But if we're looking at the z-scores, some z-scores are integers. So if I had a z-score of -1, that would mean that my z-score fell right on that first standard deviation to the left. But then I might have a z-score that falls somewhere between, and it's not a whole integer. So when that happens, let's have a look. Let's say here on this next slide that I have a z-score of -1. So here's my z-score of -1, and I want to know how many people in the population are projected to have a z-score less than mine. So I would just add up the percentages to the left of my score. Well, adding those up, it looks like about 15.8% of the population have a z-score smaller than mine. Well, to find out what the rest of the population have, I just take that 100%, and yes, even though we have a horizontal asymptote and it's really 99.99999%, we still just call it 100% because the rounding leaves such a small error. So here we have 100% minus that left side, and that will give me that 84.2% of the population have a z-score greater than my z-score. So that's how the z-score works that way. Let's have a look at the next slide here, and we're going to look at a couple different z-scores. So we just talked about a z-score of -1, but what if we had a z-score that did not fall on an integer? Well, let's say I have a z-score of 0.75. which probably would have been close to the z-score in that Duke sleep study if you had 8 hours, if I kind of remember correctly. But a z-score of 0.75, well, here's from 0 to 1. And you guys remember when you're dealing with a number line, you know, you have, this is 0, this is 1/2. So somewhere between 1/2 and 1 is going to be my 0.75. So here, my z-score is 0.75. Now, what if I had a z-score of -2.36? So here's -2, and then 0.3 is about 1/3, right? So about 1/3, it looks like it would be right about here. So when I'm recording my z-score, it's always calculated by how far from the mean does that score lie? Well, this score that I have marked right here lies 2.36 units from the mean in percentages is what we're dealing with units. All right, let's keep going on. We're going to look at something fun and interesting you may have never seen before, and that is a z-score chart. Well, like we just said, when we were looking, let's go back to this slide. When we were looking at this slide, we had our standard deviation of 1, and up here, you can see I recorded adding these percentages together to come up with the percentage. But when my z-score is somewhere in the middle of my standard deviations, and then I cannot actually calculate the value because it's just not that easy. Sure, you can do, let's look over here. If you come over here to that 0.75, you might look here and, you know, be able to manipulate taking off 75% of that area for that section and, you know, doing some calculations, and you can get pretty close, but this is a curve. So finding the area under a bell-shaped curve actually requires some calculus. So instead of doing the calculus to find out, we can't just subtract 25% of this whole area, because the area to the left of the red line is greater than the area to the right of the red line. So we have to think about all kinds of different things. And instead of doing calculus, we use our z-score chart. And I tell you that to make you more appreciative of the z-score chart. If it aggravates you or it seems small or tedious, just remember you don't have to do the calculus to figure this out. All right, so let's go ahead and take a look at the z-scores that we've already discussed. I'm going to start off with -1 just because that's easy. Negative, if you look here at our z-score chart, on the left-hand side are negative values under Z. We're going to ignore everything else for just a minute. And then over here on the right-hand chart, my Z values are positive. So I have a negative and positive. All right, so I'm looking for -1. That was the first one. We're going to discuss -1, 0.75, and -2.36. So here on -1, I put my yellow line, and then it was just -1. So that's -1.0000, right? So -1.0, now I want you guys to look up here. Look at the top of this yellow line. See the yellow line I'm moving back and forth? Hopefully, if it's not yellow, hopefully you can see some shading moving back and forth. Let me know if you can't, so I know how to make it better for folks who can't see it for the next videos. Please always give me that feedback. I love your guys' feedback, for real. All right, so here I have 0.000. So now I have -1, period, just zeros. So this is the right column. So that means that the probability of someone scoring less than -1 is 0.1587, which just means about 16%. Remember, percent, we move that decimal 2 places and put a percent on it. So about 16%. Well, what did we come up with when we calculated that back here on this other slide? We came up with about 16%, didn't we? At 15.8. It looks like really on the z-score chart, it would have been 15.9. But it's a very small error for whatever data we're looking at. If we're scientifically trying to really report some good, tough statistics, depending on what we're reporting on, we would use many more decimals. And you can find these Z charts with even more decimals than what you see here. All right, so let's look now at, what was the next one, 0.75? All right, well, that means, oh, hold on. I want to show you guys something because you're required to actually do this in your Excel report. So now I found my percentage. So what I'm going to do here is grab my snipping tool. I'm not really sure how much of my screen, if you guys can see my snipping tool down there. But I have clicked on my snipping tool, and I am going to select this little piece. Okay, so I selected that, Control Charlie, Control Victor, and now there is that percentage. I am also going to insert a shape and get this little thing down here at the very bottom. It's called a call out with a bent line. You know, you can use, if you have a different thing to use that's better, please use it. All right, so now I am just going to set these two things up together. I want to right click on this and bring it to the front. Okay, and now I have this nice little thing. I am going to select, hold my control key down, select both of those, right click and group. All right, now I have this nice little way to report that that is my z-score for -1. All right, now I'm going to move on and do my z-score for 0.75. So that's going to bring me over to the right side of my chart. So let's move our vertical line over to 0.75. All right, you guys see that right there? That's 0.07. And then the 5, whatever is recorded in the thousandths, that column, my vertical highlight here, is the column that gives me the ones and the tenths place. And then up here at the top, whoops, up here at the top gives me my thousandths place. So the very top of that is the thousandths. So this is this is 0.75. So I have my 0.7. There's my 0.7 line. And then 0.05 is right here. All right. So now I can see, I'm going to grab my snipping tool. I'm going to grab that little piece right there. Control copy, Control Victor, and then I am going to just copy this little thing that I made over here. Oh, I'm so thankful for Control Zulu. Don't you wish you could have Control Zulu with everything all the time? All right, so I'm just replacing it with this. Always work smart, not hard. Reuse and recycle. And then you have to keep sending this to the front. All right, there we go. Now I have one more z-score to find. And when you guys see the instructions for your Excel, it's going to ask you to find these values and magnify them. And that's what this means right here. I'm magnifying them here. I'm not going to do this part for you in the Excel report because we're doing it here. All right, so now I need to find negative 2.36. Was that the right number? Yes. All right, so I have negative 2.3 right there. Negative 2.36. There we go. All right, and again, I'm just going to grab my snipping tool, grab this number. And you know, there are easier ways. If I would have selected these and put them in differently, I wouldn't have to keep moving things to the front, but that's okay. Teach you guys how to do it. All right, there we go. Now I have all three of my z-scores highlighted. And you guys are going to have z-scores for, you know, a different scenario. And this is how you're going to actually put the z-score chart on your Excel and do everything that we just did here. So that'll be fun and exciting. All right, so you guys did a great job. I hope you understand. I mean, I did a great job. Hopefully you understand what this z-score chart does and how it calculates your percentages. And when you guys look at your percentages, you know, if you see at the top of this chart how it tells you that the z chart scores percentages to the left. Okay, and we've already talked about that. So if you want to calculate which percentage is to the right, remember, you just do 1 minus that number. So for example, on this piece right here, where it's 15.87, if I wanted to calculate the values to the right of this on this chart, in that case, I would just do 1 minus that number. And we did that on the previous slide. We just used, instead of 1, we used 100%, which 1 is the whole and 100% is all of 1. All right, let's move on to what we call, well, I don't want to ruin the surprise. I think it says it on the next slide, but I just want you to notice on this slide that from the negative 2, the standard deviation, negative 2 to 2, gives us 95% of our data. So 2 standard deviations to the left of the mean all the way to 2 standard deviations of the right of the mean gives us 95% of our data. All right, and we call that area the confidence interval. So from the second standard deviation to the left to the second standard deviation to the right, we have 95% of our data, and we call that our confidence interval. And what that means is, I'm pretty sure the mean lies between these 2 standard deviations. Whatever the information is, I'm just telling you, I'm 95% confident that the mean lies between those 2 values, the mean minus 2 standard deviations all the way to the mean plus 2 standard deviations. So when we're talking about a confidence interval, we're also going to talk about percentiles, which we kind of talked about it just a little bit. But remember, when I am here at 0, I am sitting at the 50th percentile. That means that 50% of the population, oh look, I just thought of this. That means that 50% of the population sits on the left side of me and 50% of the population sits on the right side of me. Now, if my standard deviation were negative 2, well, look at my percentile. I'm in the 2nd percentile. So that means that 2%, about 2% of the population is to the left of me, and about 98% of the population lies to the right of me, you know, or my score if it's sitting right there. All right, and then what if I have a standard deviation or a z-score of +2? Well, in this case, I see that 98% of the population has a score less than mine, where only about 2% of the population has a score greater than mine. And, again, if you guys fall on the 3rd standard deviation, that's the 99th percentile. And if we're talking test scores, you're rocking it. And you guys can remember when we do our bell-shaped curves on Excel, we always take it to the 4th standard deviation. And the reason we do that is because if we only go to the 3rd, we wouldn't get that nice little tail on each side of our graph. So that's why we drag it out to the 4th standard deviation each time to get that nice little piece on the end. All right, let's see, and it looks like we are ready to move on to our Excel. We are going to calculate z-scores, calculate probabilities, and record confidence intervals using spreadsheets. So let's go have some fun doing that, and I will see you guys on Excel in just a minute. Here we are, guys. Here's our Excel portion for scenario 3. Let's go ahead and see what we need to do here. So for scenario 3, it looks like we are going to read some information that is going to come from this web page. So we'll go there. We're going to create 2 tables, and this web page is going to give us BMI scores. That's body mass index. For men and women, we're going to get some averages. We'll see when we get there. We're going to use that information to create a column. We're going to create our z-curves for this. We've done that multiple times. We're going to do a one for men and one for women. I'm going to do the women one with you and then leave you guys to do the men one on your own. And all of these instructions here are just telling us how to create those columns. Remember, we do the lower limit of the 4th standard deviation to the upper limit of the 4th standard deviation. And then in our next column, we do normal distribution. And then we're going to add another column to this, and we're going to do z-scores and do all that stuff, one for men and one for women. All right, so that's what all of that is talking about. And then we are actually going to construct our z-curve for each set of data. And then we're going to make a little table for our mean and standard deviation. And then we're going to add a little extra column that we've never used before called a confidence interval. So here we also have a BMI calculator. We're going to calculate our individual BMIs, and then we're going to mark our BMIs onto that z-curve. We're also going to choose 2 other people to get BMI scores for. So you can hopefully choose if you live with other people, choose somebody in your household, children, family members, friends. You can choose some famous person that you can Google and get their data and stick it in there and use theirs. Or, you can always use somebody similar to Big Bird's Snuffleupagus. Okay, so no matter what, you can get 2 more z-scores. And Snuffleupagus is Big Bird's imaginary friend from Sesame Street, if you didn't know that. All I'm saying is, whatever it is, come up with 2 more z-scores for BMI. All right, and then we are going to create a chart for our BMI score and those of the 2 people that we chose. We're going to color code our chart to our vertical lines that are going to show the z-scores. We're going to color code everything for us and the 2 other people that we chose. All right, we are going to then use our z chart that we talked about in the PowerPoint portion of this scenario 3, and we're going to do all that stuff that I showed you. Find the z-scores for each of the 3 people, you and 2 others, magnify them the way I showed you, and that chart, you're going to copy and paste that chart into your Excel and do all of that. And then a very important thing is we're going to look here, we're going to search the web, and we're going to find BMI scores. What is a healthy BMI score? And then we're going to calculate the probability of being in that category of having a healthy BMI score. So you find the healthy BMI score, you find the z-score for that healthy BMI score, and then you calculate the probability. So you're going to use that z-score chart again. And you may have to approximate the z-score if, you know, where you can use the formula. All right, so then it looks like we're going to be about done once we do that. So let's go ahead and open our Excel here. All right, so I've gone ahead and created this just to get us started. So you guys can pause the video and get this entered. You can see that my little chart down here at the bottom has me. I did my husband, myself, and my brother. So, and I just did that because when I created this, I was actually in Tucson, and my brother and my husband were sitting there in the living room. So that's how I chose those two. For those of you who don't know, I went to Tucson over spring break to help my granny get into assisted living. So she's happy and healthy and has all kinds of great activities and people. So yay for that. Okay, let's get started here. The first thing, I've got all this set up. You guys can see that I have my table. And you guys, you know, all I did here, well, you can look here. I actually have already done this whole problem. There it is, completely finished. That red and blue 3.5, that was just something I had done. I didn't put that on the list. So when you get all done, it'll look something like that. I'm not going to make it big because not everybody, but some folks will just copy my numbers. Okay, so let's keep going here. I am ready to go to the website to look at the BMIs and find out what kind of data I need. Don't you guys think it's cool that we can create, you guys have been creating those bell curves, the box plots, the scatter plots, finding all of that stuff by just knowing two things, the mean and the standard deviation. I think that's pretty cool. As long as you remember that you can only use those data pieces, those calculations, if your data is normally distributed. And that's beyond the scope of this course, but there are all kinds of tests that you need to do to find out if your data is normally distributed. But that would be more of a stats course, you would take that in. All right, so off we go to, here we are. This is the website that is in your chart that you're going to follow to find the data. There's a lot of data here. This can make you dizzy. Some of these reports, I try my best to find reports that are more visual for you guys to copy, the graphs and things, but this isn't too bad. You just have to dig for the information. So we are going to find the, look here, we have the results. This is the results of a study. The mean BMI score increased from 24 at wave 1 to 27.7 at wave 8. And you guys might, and then it goes on for men too. And you guys might remember in the document here, I did say to get the z-scores for wave 8. So if you wondered what that meant, that's what it is. That's what it was. And here it is right here for wave 8. Okay, so make sure you get that second data set. All right, so I have a mean of 27.7, so I'm going to go back to my document and put in the mean of 27.7. And then I had a standard deviation. Let's see, a BMI variation also increased from 1 to 8 with a standard deviation from 4 to 6 for women, 6.15. So remember, I'm only doing the women with you guys, and I'm going to leave you guys to do the men on your own. So my standard deviation for women here is 6.15. So I'm going to go back here and type in my 6.15. Okay, so now we're going to recall, I'm just going to make this bigger since I'm just using this piece for now. My mean gets to be this number. I just put the equal sign and click there, and it's going to give me my mean. And then remember that the next cell here is going to be my mean, which I'm going to lock in with dollar signs on either side of the kilo here. We should be really good at that now. And that's going to be the mean plus 1 standard deviation. And I'm also going to lock in my standard deviation because I do not want that to change. And the standard deviation there, and I press enter. Now I am going to just drag this all the way over to that side. And then here I'm going to put plus 2 times, because remember, that's 2 times the standard deviation, plus 3 times the standard deviation. You guys are probably getting pretty good at this by now. And then this one is going to be 4 times the standard deviation. All right, I am going to select, too bad I can't just copy this and paste it over here, but I can't because the numbers go backwards. So I actually just copy and paste it just like this, one at a time. And you guys, of course, can do it however you want to. I just find this easier, and then I'm going to go back through and just change each of those pluses to a minus. So I just control copied one and control pasted it in the other. Now I'm going to the other side and just changing each of my plus signs to a minus. The most aggravating thing that can occur here is that after you change it to a minus sign, you try to click in another cell instead of pressing enter. And that can make all kinds of crazy changes and frustrate you. So make sure after you change your sign to minus that you press enter to get out of there. Okay, and then I just kind of look over it to make sure it makes sense. 27 minus 6 is about, yeah, that's right, about 21 minus another 6. Okay, everything looks good. All right, so now I'm ready to create my chart, my first chart. So remember, I have these values, 3.1 and 52.3. So I am going to come over here. I'm never going to remember what that was, so I'm going to have to make this smaller. All right, so I am coming over here to the far left of my screen, and I am going to type in 3.1. All right, and then I told you guys on this Excel page here, it says to count in a scale of 1, and that just means increase by 1. So all that means is that right here, I'm going to go from 3.1 to 4.1. And then I need to take that all the way down to, come on, sorry, all the way down to 52.3. And I got that value where it says 52.3 on my 4th standard deviation. So I'm going to make this smaller. I always like to make it small when I know I'm going to count kind of high. It makes it easier. So I'm selecting that, and then I'm dragging it all the way down to, won't let me do it because of my video thing there, but I'm going all the way down to 53. It took me to 53.1, okay? All right, now I can go bigger again. And now we want our normal distribution. So I am going to type in equals NORM, normal distribution. And now I have my X value right here. Shoot, I am going to have to make this small because in order for me to get over everybody wondered why I kept everything so small on those first videos, and now you see why, because it's hard to work back and forth making things big and small all the time. All right, so I am going to put this equal sign in here, and I have my normal distribution, normal.dist, and then my X value, comma, my mean, which is right over here. I'm going to click that, comma, my standard deviation, comma, and then our cumulative is always false. And then hit enter. All right, I'll bring that back over here for you guys now. So remember right here on my standard deviation and my mean, I'm sorry, this one's my mean, and then the second one is my standard deviation. I'm locking those cells in again, locking them in so they don't move because I only want that X value to move, not that. All right, and then I click and double click that bottom right corner, and here I get my distribution, my normal distribution, random numbers, I think. I'm not really sure how that works, that command, to tell you the truth. All right, so let's look at the next part here. And the next part tells us to put in a z-score. So I am going to go ahead and label this right up here as z-score. All right, so I need to figure out how to find a z-score, and we've done this before, but let's go ahead and go to Google and ask Google for formula for a z-score.
According to Laird statistics.
All right, so we find our z-score formula. Let's see, I'm going to go to images. That always makes it easier for me. All right, here is our z-score formula. So to calculate the z-score, I just have my x value minus the mean, all divided by the standard deviation. So x minus the mean, let's just go ahead and snip this. Oh, I like this one. I'm going to use this one here. I'm going to copy that, and I'm just going to paste it into my, oh, come on, into my Excel. It didn't let me paste it because I was clicked in a cell rather than just being generically clicked on the document. All right, so here's my formula for the z-score, just so I know. So I have, remember our order of operation. My numerator is a number minus another number, so I have to put that. We did that, I think, on the last Excel or the one before, I can't remember, but we have our order of operations we have to remember. So I have the value, which is your x value here, minus the mean. So the mean, uh-oh, where is it? The mean is right here. I think, I don't know if the next one is a standard deviation. I'm just going to click it just in case. So when I get back over there. All right, so it's the value minus the mean. And then I'm going to put parentheses and then divided by the standard deviation. So I have everything on my formula here. Remember again, we do need to lock in our mean and standard deviation with our $sign. And I get a z-score of -4, which is exactly right, isn't it? Because what was that value of 3.1? Well, remember 3.1 was the value all the way to the far left at the -4. And remember we discussed that standard deviations are z-scores. So that makes me feel very confident that I am on the right track here since it reported the correct z-score. So I'm going to copy that, select that cell. Maybe I've got something going on here, I don't know what. I'm going to pause the video and find out. Okay, I don't know what was wrong, but it's working now. So I select the cell and then go to the bottom right corner and double click. And voila. And of course, I can go back and check other values. This moving around is a little frustrating. I understand. It's probably making you guys dizzy. I'm going to go check the value of, I don't know, what about 27.7? What should my z-score be for right at the mean? Well, 27.7. Look at my z-score there. It is very close to 0. You can see that between 27.1 and 28.1, I crossed over from negative to positive. So my z-score of 0 is falling right where the mean is, which is perfect. All right, we are really getting somewhere. And of course, you guys are going to do all of the same thing for your min. Also, let's fill in our confidence interval here. Well, do we remember what the confidence interval is? I could fill that in now. We may as well. Remember, the confidence interval is the second standard deviation from the left to the second standard deviation on the right. And the way we report that, this would be written as 15.4. And I'm getting that value from this, I'm saying this cell, but I have no way to point to it here. Do I have any? Hold on a second. Okay, I have my little box here. I need a command that lets me instantly do that. All right, so my confidence interval, remember, came from this 15.4 right here. And then it goes all the way to 40. So it goes from 15.4 to 40. And it's, you know, plus or minus any values in between that. So to report a confidence interval, we really have a plus or minus here. And we have a couple different things. I can't just put 15.4. I can do this two ways. I can either put 0.15, 1.154, and 0.40, or I can put 15.4% or 40%. And I did pull, and then you see how I wrote my plus or minus? This is so generic because I could not find the right symbol anywhere. I Googled it and everything just looked real complicated. So I gave up for now, and I'll find it again another time. But for today, I did have to give up. But here you can see this. My confidence interval is written like this. This is the plus or minus sign right here that I can't find on Excel. So if you guys find that, somebody please give me the reference number, or if you figure out how to do it, I'd really appreciate you showing me in your video. So I can either record that as a decimal value, or I can record it as a percentage. So that's how we write a confidence interval. For this particular one, we have this 0.154 plus or minus 0.40. And I'm just going to make this whole thing a little bit smaller to make it fit better. Okay, so now I am going to create my bell-shaped curve. I'm going to make this small again. I come over here to my data to create my curve. Remember, I just select the two cells on the left, and then I am going, I don't know if this is going to work. Yay! I just selected those two cells and then double-clicked. Sometimes it changes things badly, and if that happens, you just press Control-Z and then just physically select those two columns. Once you do that, you are going to insert a scatter plot with smooth lines. We should be super good at this by now. We are then going to label our chart here. I always just like try to get the mean right in the middle. It doesn't really, it's kind of hard to get it lined up, but you can, you totally can. All right, so there I have that, and of course I'm gonna label my chart as BMI scores of American women. And you guys, you know, yours will be better than mine, of course. All right, now I always have to do all these extra little things, don't I? All right, so now I have my bell-shaped curve, my chart. Another thing that I want you guys to put on here is the usual. I'm gonna come over here and copy it from this Excel report, and you guys can copy a lot of stuff from your other Excel reports. Just please make sure that for this module 3, you have a fresh Excel report. And if you didn't know what I'm doing over here, I'm holding down my control key and I'm just copying this, bringing it back over to the other Excel report and pasting it in. All right, you guys have all of this also on multiple other Excel reports, so use it. Work smart, not hard. All right, so cool. I just grabbed that from another one. We've learned that these blocks are all the same percentage. If anybody wants to get clever and do half of percents, I mean half deviations, you know, feel free to give that a try. It'll just be more work. All right, so there is that. What am I gonna do next? Let's go to our document and find out. So we created all of our tables. We constructed a Z-curve chart for our data. Add a column to the mean and standard deviation and list the confidence intervals. We did that already. Use the BMI calculator to find our own BMI. So I am actually, well, let's see, I'll just do it. I didn't plan on doing this part, but let's just go ahead and do it. I'll just do the women's, and since I'm a woman, we'll do mine. All right, I am going to this link here, and you guys can just click on yours. I have mine in a Word document. It opens in a weird I don't know, some browser I don't use. All right, here is the calculator. This is super cool, you guys. I encourage you to read this data, learn about yourselves. What is a BMI? How does it tell me anything about me? Some people, like Tinny, for example, Tinny is, I hope you don't mind, I don't think you mind, he's got a heavy mass, he's dense. That didn't sound good, I know, but I mean that he's heavy, but his BMI makes him seem overweight, but then he's not. So you guys sometimes, like in the military, for example, I remember, if people were overweight with a BMI, they had the opportunity to have their neck, they called it having their neck taped. And that just meant measured. The circumference of your neck, if it was a certain circumference relative to your body weight and your height, then you were not overweight, even though your BMI showed you were overweight. So the BMI is not always the perfect calculation, nothing is, but it is very, you know, it's not very, but normally accurate. So we can use it with a lot of confidence. And if it says you're overweight, but you know you're not, you can probably still see that it's pretty close. All right, so let's see. I am, oh look, I see I've already done this. I am 5 foot 4 inches. Really, I'm 5 foot 3 5/8. And my weight is 127 pounds. And for those of you who don't know, my weight used to be almost 190 pounds. So I'm very excited to get to put that 127 in there. Actually, almost brings tears to my eyes. And I know there are a few of you out there who know exactly how I feel, which I've talked to you, and that's awesome. It's not an easy task to get healthy. All right, my age is 46 years old. I am, are you Asian or Asian American? No. And there's other information here that it gives you. I had put in here that I wanted my weight to be 125, and it gave me this big report saying that I didn't need to lose weight and stuff. So it's actually pretty cool, like all this stuff that you can put in here, and it will tell you things about yourself. All right, so here I find that my BMI this year, yay, is in the green. So when you guys put yours in, if it's not in the green, then you might want to look at some different ways to get it in the green, because a healthy BMI is important. So here my BMI is 22. Can you guys see that? It gave me my calculation of 22. And then, you know, like I said, if you fill in all that other stuff, it'll give you more information. It's a pretty cool little calculator that we found here. All right, so my BMI is 22, so I'm going back here to the Excel report. And I have already put mine and my husband's and my brother's already in there because I did this, as you saw. And now I want to know some little charts. So I'm going to go back to my other one. I'm just kind of cheating a little bit here, and it's only probably something I could do just as quickly, but I just grabbed a line. Oh. All right, so what I'm doing right now is we are going to color code a little line to mark on the bell-shaped curve. And you see my line here is black, and I'm going to go at 22. So it's a little bit hard to see my x-axis here. I'm going to go ahead and click my x-axis. I am going to make my numbers bold, maybe. Oh, it only gave me one. All right, so I'm going to, I guess I can't. I was going to try to make my numbers bigger and bolder, but it's only, looks like it's only doing one at a time on the bold. All right, so here we are. It did work. It's just because I have these charts on here that made it look like it's faded out. That's all. And I can actually, you know, move these up if I want to. Ha, how about that? Doesn't that look good? Yay. All right, so now I can really see that, and these are labeled by tens. I can change my x-axis to be the C right here where it says major, it's labeled by 10s. I can have it go by 5s. Or I could even go by 2s, but I think 5s are good. That looks really good. I'm liking this. My BMI score was 22, so from 15 to 20, 22 is about in the middle. Whoop, sorry. From 20 to 25, 22 is just about in the middle. And to tell you the truth, this is kind of driving me crazy. I'm just going to see what happens if I count by 2s here. Oh, I like that. It's a little busy, but it makes 22 really easy for me to find. And then when I calculate my brother and my husband's Larry, he's going to be blue. He'll have a blue line, and Tim will have a red line. So we just want everything color-coded, and I'll just show you guys really quick here how this looks. So here you can see when I did it, I have my line is on the women's, which is black, and then Larry and Tim are over here, and they're blue and red. Okay, so that's what it means by color coding that stuff. All right, so let's see now what. I want to calculate my Z-score. Well, my Z-score is going to be calculated by, you know what, I just realized I can do this. I'm going to come back over here to my Z-scores here, and I am just going to copy this whole formula. I didn't think about this earlier. The more times you do something, the more cool, easy stuff you think of. So here for my Z-score, my mean and my standard deviation are still the same, so that's perfect. And for my X value, I'm just going to change it to that cell. And it looks like I have a Z-score of negative 0.93. You guys see that? I can even click this cell, whoops, one click, and move my decimal place over, because remember my chart only gives me 3 decimal places to the thousandths. So, or is it to the tenths? Hundredths, I meant to say. I think it only goes to the hundredths. So negative 0.93. And I am not going to do all of this with you guys, but I'll go ahead and show you mine, how mine looks here. When I went ahead and did this, you can see that my Z-score of 0.93 is right here, 0.93. And then, see, there was mine. I had 0.18, so 18, that means that for me, 18%, let me get this thing over here. 18, about, oh, come on. About 18%, oh, I see. It's okay, send it to the front. So here's my Z-score, and it looks like about 18% of the people have a BMI less than mine. So that means that 1 minus 18% go the other way. So let's get into this calculator right here. What did we say mine was? It was 0.1814. 0.1814. 0.1814. Okay, and then that means that the other side of the people are going to be 1 minus this value. Okay, and I've already gone in here and made this into a percentage. So you guys will have to select these cells, turn it into percent, and if you've already typed your numbers in there, you'll probably have to change it. You're familiar with that by now. So now I know that 18.1% of the population are projected to have a BMI score less than mine, and 81.9% of the population are projected to have a BMI score greater than mine. So that's what we're looking at here. All right, now let's see what else we were supposed to do. Get the calculator, find the 3 BMIs, the 3 Z-scores, record the percent of the population. Let's get back down here. Where does it say that? Record the percent of the population with projected BMI scores below and above yours. We just did that. choose a different color. We color coded, use the z-score chart, and use your snipping tool to capture. So I think the rest you guys have got that. If you look at the 5 sentences that you're required to write between the PowerPoint presentation portion of this lesson and the Excel lesson, you should have that down and be able to get that calculated. So you guys, we finished scenario 3. And for this particular Excel report, scenario 4 is the longest, but still not complicated. So I'm super excited. You guys are halfway done with your last Excel report that you're going to do with me. So I will see you on scenario 4. Until then, keep being amazing. You rock.